So in this video, I'm going to look at the way we create walls, floors, roofs within Revit. These are obviously the fundamental building blocks of our project and our model, and they are very similar in the way they work, but we'll look at the way we construct each of those in turn, and then at the end I'll look at the way that we draw lines within Revit. We have two different types of lines and they behave differently. So let's start with the floor tool. So up in the ribbon in the architecture tab, we have a floor tool. If we drop that menu down below, we've got some options for different floor construction methods, but we're just going to use the floor architectural, which is the default floor construction tool method. When we click on that tool, the tool activates, and you can see that all the other objects in our window have gone grey. We're now in a floor creation tool sandbox. We're effectively away from the rest of the model, and we can create a floor without affecting any other objects within the model. We can still use the other objects in the model for references, and we can attach lines to it, but we're not actually going to change anything other than creating a floor in this mode we're in. You'll notice at the top the ribbons change. We've got this little section at the end. We're now in the Modify tab. We have the green tick and the red cross. These are common in Revit. This allows you to either accept whatever you're creating and bring it into the model and return back to the main drawing menu or drawing area. That finishes the editing. If you hit the cross, you'll discard whatever you're doing and go back to the main drawing area without saving any of the changes you're making. So these are in many tools and you'll see them a lot. Next to that, we have the way that we're going to create our floor. So we can create it by using a slope arrow or a span direction. We're not going to look at those at the moment. The most common way of defining a floor is to define its boundary edge. So we draw some lines, it tells Revit the shape of the floor, and it then builds the floor to that shape. So we're going to use boundary line, so make sure that's clicked. And next to that we have a box with drawing tools. Now these drawing tools appear in a lot of the tools we're going to use to create objects, but the actual tools themselves, the ones you get, vary depending on what tool you're in. But these are where you use these tools to define the lines that make up the edge of our floor. We have another 4 icons to the right that deal with work plane. We're not going to deal with those at the moment. So these are where we define the edge of our floor. Before I dig into that, you'll notice in the properties panel, we're in the floor creation tool. Revit is telling us what the floor is that we're going to be using to create. The floor type, sorry, that's in here. By default, it picks whatever the last one was that you used. If I click on that drop down, I've got all these selections of different floor types, floor constructions. Whichever one I pick will be the one that gets used to define and create the floor. So if you want to, you can pick the floor type before you draw it, or alternatively, you can alter the floor type once you've created it just by changing its type in its properties. Either way, sometimes it's easier to create a whole lot of floors that are all the same and then modify them later to the types you want, or sometimes it's easier to actually pick the right floor and draw it with the right floor type selected. Underneath that in the properties panel, because we have no object selected, Revit is telling us the properties in here of the floor that we're about to create. If we wanted to, you can see here that the floor level, because we started drawing in level 1 floor plan, the floor level has been associated with level 1 floor level. I can change that to either of the floor levels in my model at the moment. And that just means when I draw the floor, it will automatically attach or host on the floor level that I have selected. I can actually also get the floor to be drawn above or below that floor level by an offset, and I can alter where the floor appears. I can also change whether the floor is a room bounding floor. I'm not going to touch on that at the moment, but we can actually change these things before we draw the floor, and it will apply to the floor as we draw it. We're just going to leave it set on level 1, so the floor itself will live on floor level 1, and there'll be no offset to that. So if we go up to our drawing tools, we've got line tools, we've got a rectangle, we've got polygons, we can do circles, splines, arcs, various other things. We can actually select other lines that are already in Revit and use those. But let's just start with the boundary tool and we use the line tool. So when I click on that line tool there, you'll notice this little section of the ribbon got some options appearing. The first one's chain. So this basically says that I can click a line click on the drawing to start the line and click again, and it will continue drawing lines until I stop it using the escape key. If I untick that, each section of line that I want to draw, I have to start and stop, and then start the next section and stop the next section. So normally by default we leave that as chain. We can offset the line. So if we're drawing a line that's following something in our model already, but we want the actual edge of the floor to be 100 mils off that or a meter off that, we can set an offset here. And when we draw the line, Revit will create the edge of the floor whatever distance away from our line that we've set. So we won't touch any of those at the moment. We're just going to draw a line and it will define the edge of the floor. Now we're using a line tool. We can draw any shape we want. Revit will try and snap to vertical and horizontal or a set angle as you're drawing these lines. You can see as we draw the line, it gives you a dimension with the length of the line and the angle that it's set to. We can just randomly draw some lines to get this underway. As you're clicking around drawing, as I said, it will actually use the objects in the model already to attach to. If you have some objects, when the cursor changes to a square, you're snapping onto the endpoint. So these are snaps. If it's just got a cross and an object underneath turns blue, that means you're attaching to it somewhere. You can be at right angles to those as well. So there's various snaps we can use to generate our lines. But we'll just, for this example, just draw some random lines. But we need to make sure that the floor boundary is a full enclosure. You can't have a floor that doesn't have a complete edge. So as we get back towards the start point of our lines, if we hover over that, we get an endpoint, we get a square that indicates that's the snap for the endpoint. If I click on that, we've now completed our line that encircles our floor. We're still in the line drawing tool. To get out of that, we just hit escape, and we're now in the line drawing tool, but we're not actively drawing a line. So we've now defined the edge of our slab. If I just click OK, it will generate that floor slab based on that line. Before we do that, I just want to touch on another part of the line drawing and the defining the edge of the slab. Revit will interpret whatever you draw as being the floor slab, and it will try and work out what parts of the slab are solid and which parts are cutouts. So for example, if I want to create a hole in the middle of my floor that's circular, if I draw a separate line using the line tool in there, hit escape to get out of that command. So I've drawn a circle within the overall outline of my floor. Revit will interpret that as being a hole within the floor. If I draw another circle inside that, it will interpret that one in the middle there as being a solid piece of floor in here, this being a hole around the outside, and this being solid floor in here as well. So you can create quite complex shapes within Revit, and within the floor tools, and the roof tool as well works the same way, just by drawing multiple shapes that are completely enclosed, and Revit will try and interpret them as to what's solid and what's not. So we hit the green tick. This will define our floor, create our floor on the floor level 1 as defined over here, and it will be 100 mil concrete with 150 mil hard fill underneath. Let's just click that. When you click out of the tool, the floor you've created is selected by default. If you click away, you can see the floor is there. If I hover over it, you can see the shape of the floor. And if I open up a 3D view using this little icon at the top here, we will see that we've created a floor which is solid, has a hole in the middle, and another little island piece of floor slab in the middle again. If I rotate around that, you'll see that I actually can see straight through the middle of my floor. It has actually got a hole in the middle of it. If I open up the elevation here, you'll see that the floor slab is created, hosted on floor level 1, as we told it to, and it's created the top of the floor slab level with that floor level. So the floor level Revit decides is the top of the floor slab, and the floor itself gets created underneath that. But we're not stuck to that. Even though we've created it on floor level 1, we don't have to leave it there. So if I click on the floor slab object, the properties panel comes up with the properties for that object. We can see what the type of floor is, and we can see here that it's created on level 1. If I click on that, I can change that, or there's a little drop down here, and that will give me all the levels in the model. So if I don't want that floor in level 1, I want it on level 2, click level 2, back into the drawing area, and it's now moved the floor up to the next level. if I want to put it back to level 1, I can do that. So that's a property of the floor. The floor level it is on is a property of the floor itself. You notice underneath that level 1 there's an offset. So this says offset. I touched on this as we were creating the floor. If I want the floor to be 500 mils above the floor level, I put an offset in there and it will move the floor 500 mils up. If I want it to be 500 mils below the floor level, I put a minus number in there and it drops it down below. So we can change the location in terms of height of the floor once we've created it. I'm going to put it back to where it was, level 1. If I go back into my floor plan, once we've created a floor, if I select it, in the top here, we're back in the modify section of the ribbon, there is an edit boundary button. If I click on that, we go back into what's effectively the floor creation tool again, and we're back in this location with all these draw tools and various other things up here. So we can modify the shape and size of our floor based on what we want to do to it. We're basically recreating the outline. So the floor is defined by these lines. If I move some of these lines around, so for example, what was my little island of slab in the middle here, and this is a hole around it, if I drag that across into here and reconstruct the floor, I've now got 2 holes in my floor. It's taken what was an island, and because I moved it into a solid part, it decided that it was in fact a hole in the floor, not a solid piece. So we can manipulate and change the floor once we've created it. And we can do that in a 3D view as well. So I'm in a 3D view. If I edit the boundary, I can now see the outline of my floor in a 3D view, and I can manipulate it if I want. But I can actually change views within Revit while I'm in this floor editing tool or the floor creation tool. So I can flick back to the floor plan. If I wanted to go to level 2 to do it, I can do that. I can open new views. As long as I'm still within the floor editing or floor creation tool, I can change views to suit what I need to. And sometimes you'll need to change views to get the right angle, to get the lines where you want them within the outline of the floor. So you will have to change views to do that. So we can do that once we're in there. So we can edit our floor to our heart's content and it will generate the floor. If I go back to my elevation, you'll see the floor has thickness, and that's based on the floor type that we used. If that's not the floor type that I want to use, I can select the object, drop down the floor types, and I can change it to say 150mm slab, and it will change the type of floor that I'm using. So that's how we generate floors within Revit. Now I'm just going to delete that one and create a more simple one for the example that we're working on, because I need to create some walls next. The floor tool here, for some reason the floor tool doesn't have the keyboard shortcut, so we have to click on it every time. I'm just going to generate a nice rectangular floor, just like that. So again, in 3D we've just got a nice rectangular floor that we're going to use to build a little building. The next tool is walls. Walls is a WA keyboard shortcut. It's worth knowing that one because you do use it a lot. But we can click on the wall icon to generate the tool. We have a drop down underneath. We've got a few different types of wall that we can create. We're going to be creating an architectural wall by default. So we click on that. And again, we go into the modify tab on the ribbon and we get the tools to allow us to draw some shapes to define the wall. To define a wall in Revit, we're drawing the center line or a line that is the shape of the wall in plan. Walls generally are vertical, therefore you don't need to define the shape of them in the other direction. All you need to show is where the line of the wall is in plan, and Revit will generate the wall based on that. Again, as well as the draw tools up here, we get this line below it with some other options. So I'm going to run through those just to explain what they do. You can manipulate these options before you draw the wall and it will affect the wall you're drawing, or you can change them afterwards. All of these things are changeable afterwards. So starting over here, we've got the height of the wall. That's normally default as height. There is a depth as well, but we use height. It just means the wall goes upwards above the floor rather than below the floor. Next to that, we've got, you can't read it very clearly, but it says unconnected and level 1, level 2. When we draw the wall, we can either have the top of the wall unconnected and give the wall a height, or we can tell Revit that we want the top of the wall to connect to one of these floor levels. So we could draw a wall that the base is on level 1 and the top of the wall attaches to floor level 2. We're just going to leave that as unconnected at the moment, which means we'll draw a wall that sits on level 1 but has no constraint on the top. And we can define the height of that wall as we draw it by putting a number in here. So if we change that number to 3 meters, when we draw the wall, it will be drawn at 3 meters in height. Again, we can change these afterwards, so it's not critical that that's what you want, but it allows you to set the height of the wall as you draw it. I'm going to skip the location line for a second and we'll come back to it. Chain, we've touched on this with our line drawing in the floor. This just generates a chain of walls, so as I draw the wall, I don't have to click the start and end of each wall section. I just click the end of it and it will attach it to the previous wall that I drew. Offset, again, we can offset the line of the wall as we draw it. So if we want the wall to be 100 mils or a meter off from the line we're going to use to define the path of the wall, we can set that in here. Again, we can change this later. Radius we will ignore, and we can allow the wall to join. So what this does is it joins the pieces of walls together as we draw them, and they become effectively a continuous piece of wall for manipulation purposes later on. So we leave those pretty much as default. The one I'm going to touch on and talk a little bit about for a while is the wall centerline. So this defines where the wall is generated in terms of the line you're going to use. So I'm just going to get out of the wall creation tool for a second, and I'm just going to draw a couple of lines on my drawing. Another tip is that if you've used a tool once and you've escaped out of that tool, if you hit enter on the keyboard, it will generate or activate that tool again. So I wanted to draw another line. I don't actually have to click the draw the line tool. I just hit enter and it will activate the last tool that I used again. I've just drawn some lines on my drawing here. I'll just get rid of that one. And I'm going to use these to demonstrate how the center line of the wall works when generating walls. So if I go back into the wall tool, that's WA, the wall. This tool here, by default at the moment, is set to wall centerline. If I drop it down, I've got 6 options. The wall centerline, the core centerline, the finish face exterior, finish face interior, core face exterior, and core face interior. So Revit, when it builds walls out of various materials and builds them up to actually be realistic to the actual physical construction of the wall, it uses something called a core. It divides the wall into 3 parts. It has a finish on the exterior, a finish on the interior, and the core. The core is the middle section of the wall. So on a timber frame wall, that would be our timber framing. The finished exterior would be the linear or the weatherboards, and the jib on the inside would be the finished interior. So I'm just going to draw a wall, and hopefully that will explain clearer what I'm talking about. Before I draw the wall, I can change the wall type, the same I could do with the floor. So I can pick a different type of wall if that's not what I want. Again, we can change it later, so it's not critical you get the right wall type when you draw it, but we can select that wall type that we want. So at the moment I've got a 90mm timber wall, 25 linear and 10mm jib. So I'm just going to draw the wall. I have the location line set to wall centerline, and I'll draw my wall. So all I do is click at the start, click at the finish, and you can see it's still got the tool active, and if I click somewhere else it will generate another piece of wall. So as many times as I click, it will just keep generating sections of wall, and it will join the gaps between those sections of wall. I don't want those at the moment, so I'll just delete those. So I've drawn my wall here, and I've used the wall center line when I drew it. So I drew along this line here, and it generated the wall equally on either side of that line. If I dimension that wall, I'll just drag these out. You can see them. You'll see that the dimensions of the wall are equal on either side of the line that I used to generate the wall. So it has used the overall width of the wall, and it's split it in 2 and then positioned the wall equally on either side of the line that I was using. If I draw a wall again, same wall type, same construction, but instead this time I use the core center line and I draw on the same line, it looks initially like it's in exactly the same place. But if I dimension this wall now, I use two separate dimensions, you'll see that the wall is not centered on that line anymore. It's slightly offset. What it has done, Revit has taken the core, which in this case, I draw another piece of wall to make it clear. This section in here in the middle is the core. This is the finish on the exterior side, and this is the finish on the interior side. Revit knows how wide that core is, and in this example here where I've used the core center line to define the wall location, it has used the middle of the core to generate the location of the line. So it's centered the core on the line I was using to define the wall. So we can see the overall wall is now offset. I delete those and I redimension the wall to the core. You'll see that the core, which is that section in there, is centered on that line. So we can get Revit to draw the wall at a location that suits us as we want to generate it. Now you may wonder why this is of any use, but if you look at some of the other options that we have in that drop-down list, you notice that one of them is the core face exterior. This is probably the one we use most often. So we can get Revit to line up the line that I use to draw the wall with the exterior of the core face. So in this example here, this is the outside of our wall. It will be this line here, will be the one that lines up with the line that I draw. So just to show what that does, if I change the core face exterior and I draw my wall along this line, you'll see that the inside of the finished product, the linear weatherboard in this case, the inside of that now sits on that line that I've used to draw the wall. Again, we can change that later if we want to. So why would that be useful? So let's delete all that. If I want to draw my wall and I've got my floor slab sitting here, which I've already created, I go into the wall tool. If I draw the wall center line as the line that defines the wall, when I draw my wall, half the wall is hanging outside the edge of my floor slab. In terms of physical construction, that's not how we build the wall. We would build the wall with the outside of the core, in this case the timber framing, touching the edge of the floor slab. So we can actually get Revit to draw the wall in the right location as we draw it. So if we set that to core face exterior, so the exterior face of the core, timber framing in this case, will now sit on whatever line I use to define the wall. And in this case, I'm going to use the existing slab to define that line. So I'm in the wall tool, I'm in the drawing line section here. Whichever line I draw will define where the wall goes. I can use existing objects within the model to define that line. I could draw the wall along the grid line. I can have it start on the edge of the slab here and follow the slab line around. So I can use existing objects to define that trajectory or the plane of the wall. So I'm in the wall tool. I click on this point here, this end point. This is the end point or the corner of the floor slab. I click on that, and as I go around the floor, you'll see that it's now drawing the wall with just the cladding hanging over the outside and the core, the timber frame itself, sitting inside the line of the slab. And if I just click on the corners of that slab using the snaps, it will generate a wall all the way around. I'm going to go back up to here. Again, if I click on the edge of the slab, which is in here, and Revit will close the wall up to form a continuous line of wall. If I go to my 3D view and zoom in, you can see that the cladding now is overhanging the floor slab, which is exactly what I want. You can move it another 6 mil if you want to do the 6 mil overhang, but this is as good as we need at this stage. So we've generated the wall so it lines up with the edge of the floor slab. And these walls are all this 90 mil timber, 25 mil linear construction. And that's essentially how we define walls and generate walls and draw walls in Revit. We use the wall tool, we pick a wall type, and we draw the shape we want. And we can have complicated shapes, we can define circles. If we really want a circular wall, we can do that. Revit will happily do that. We can do arcs, we can do all sorts of things. And we can connect walls together and change their types. So the wall tool is very simple. All we're doing is generating lines that represent the line of the wall. Once we've got the wall constructed, when we drew the wall, so I'm just trying to find an elevation. When we drew the wall, we told Revit what the height was. We wanted a 3 meter high wall that was unconnected to anything else. Once we've drawn the wall, we could change the height of that wall very easily. We have these grab handles. If we select the wall, just undo that. If I select a wall, we get these grab handles at the top and the bottom. If I click and drag on them, we can adjust the height of the wall. You'll notice there's a dimension on the side here that adjusts as we move, so we can see how high it is. Once we've got that dimension visible, we can actually click on that dimension and use that to define the height. Or in the properties panel, we can just adjust the height here. So we can put that back to 3 meters. If we want to do that to multiple walls at a time, if we go to a 3D view and we click on, hover over a wall and hit tab, it will show us all the walls that are connected. If we click on that, we get all those walls selected. And we can change all of those walls at once in our properties panel to a new height, and it will change them all to suit. I talked when we were generating the walls that we can actually connect them automatically to a floor level above. So once we've selected a wall, or we've got a wall selected, or multiple walls selected, you'll notice in the properties panels where we were changing the height of the wall, immediately above that is the word unconnected, and that's the top constraint of the wall. If we drop down the menu, now you may be wondering where the drop down is. You can't actually see the drop down in this little panel. You'll learn where they are, but if you do click on the box, you'll see there's a drop down. The end here, drop that down, we get the 3 options we have available. We can have an unconnected wall where we define the height of it, which is what we've got now. We can get it to connect to level 1, which is actually the level that it's sitting on at the moment, or we can get it to connect up to level 2. If I click on level 2, the wall will automatically go up and join to that floor level. So if I click on that, so the height of the wall now is defined by this floor level. Just that one wall, all I did was change one of them. So we've got one that's slightly higher than the rest, but that wall now is attached. If I select that wall, you can see that its top constraint is up to level 2, and it has this top offset. So again, I can still make it above or below that level, but that's the level that it is attached to at the top. So if I want it to be 500 above the level, I can put an offset at the top there, and the wall itself will appear 500 above the floor, but it is still constrained by this floor level. I can use a negative number or whatever in that offset. If I put that back to 0, you may be wondering why that's why it works like that, why even though it's not visibly at the same height as that level, why we still want it attached to it. And that's because this wall here is attached to this floor level at the top. It's attached to this floor level at the bottom. You can see here there's a base constraint of level 1. If I move that floor level, the wall will stay attached to it. So at the moment that's a 3 meter height above level 0 or floor level 1. If I make that 5,000, you'll see the floor level has gone up and the wall has gone up with it. So if you draw your building and you attach all the walls to floor levels and then use offsets, if you change the height of a floor within the building, all the walls that are attached to that floor level will go with it and retain the connection. So this is why we would use the connection and the top constraints or the bottom constraints. If I undo that, we'll go back to our floor level that we had, which was 3,000, and the wall comes down with it. You'll notice the other walls didn't move. Those walls are not connected. This one here, for example, is not connected to this floor level, so when I move the floor level, nothing happened to that wall. So that's why we would change the way that walls are connected to floors. We could do the same to the base of that wall. We have a base constraint. At the moment it's level 1, and we can have an offset. Again, if we want that wall to be 500 above the floor level, we just put that information in there and it will generate it. If we want the bottom of the wall to actually not be attached to that floor level at all, we can change the floor level that the wall sits on. Bear in mind that if I have a wall that's attached to both of these floor levels, if I tell it to move the bottom of the wall to that floor level there, which the top is attached to, the wall will disappear. And I can change the location of the wall by changing the base of it. So let's work on another wall just to clarify the point. So we use this wall here now. Let's open another elevation. So we're now looking at a different wall, and I'm going to show you how you can move the wall from one floor to another. So this wall is unconnected at the top. It has a height of 2400. The base is connected or constrained to level 1 with no offset. If I change that level 1 to level 2, the wall will magically pop up to the next level. So we can easily change a whole lot of walls and where they're located within the building by changing the base of the wall. If I go back to the 3D, I'm going to change that one back to unconstrained, unconnected. That's fine. Again, if I hover over one wall, hit tab, select all the walls, I can change them all from being a base constraint of level 1 up to level 2, and all the walls will move up with them. So this is a quick way we can move walls and their height within Revit. If I undo that, and I go back to the floor plan, if I want to change the shape of the wall, all I have to do is basically click on the wall. If I'm on a floor plan, at the end of the wall we get these drag handles. I can grab one of those and just drag the wall around, and we'll actually move the location of the wall. I can click on the wall and drag the whole wall out, and it will move the location of the wall. You'll notice that this wall is joined to the wall next to it. We told Revit to do that. So when I pull the wall, the other wall goes with it. But I disconnected it from this end before I moved it, so it doesn't connect anymore to here. So we can move the walls around once we've got them in place, simply by dragging their handles. I'm just going to put my walls back where they were. Let's adjust that one back to where it was. And let's look at the last tool I want to cover, and that is the roof tool. So the roof tool works similar to the floor tool in that we generate a boundary for the roof, and Revit will generate the roof based on what we tell it is the edge of the roof. So I'm now in my level 1 floor plan, and I'm going to click on the roof tool and start building a roof. The roof tool's up here. Again, we have some other alternative ways of building roofs and other things we can do with roofs, but by default we use the roof by footprint. If I click on that tool, I get a little pop-up warning. So we're in the level 1 floor plan, and we're looking down at the floor level that is level 1. So we're at the lowest level of the building, looking down on the ground floor effectively. Revit's saying to us in this little box, you're trying to draw a roof. Roofs don't normally live on the ground floor level. You're at the lowest level of the building. Do you actually want to put the roof somewhere else? It's giving us an option of different levels we can use. If we drop down this menu, we can see we've got level 1 and 2. If you have more levels in your building, that will appear in this list. And you can tell Revit where you want the roof to be hosted once you've drawn it. So again, this idea of hosting, the floor level has to be defined for the roof when it's created. It has to host on a floor level, and we can pick which floor level we want to use. And we don't want to draw the roof on the lowest level that we're on, so let's pick level 2 and click yes. Now the problem with this is that we're actually looking at a floor plan of level 1. If we draw the roof on level 2, it'll actually be above our head effectively, above the line that we're looking at. So we can't see the roof when we draw it. We click yes, and we go into a tool that looks very similar to the floor tool. Now before we start drawing the roof, I'm going to change the viewer in because I can't see the roof as I draw it. If I draw it here, because it's appearing above me, I can just click on the level 2 tab, and I'm now in the level 2 floor plan, and the roof is being drawn on level 2 floor level, which I can see in this view. Again, before I draw it, I can change the roof type. I've got a whole lot of different roof types, and you can generate new ones, and it's ideally you want to pick the right one for what you're drawing, but again we can change those later, so it's not critical. So we make sure we got the right roof type selected. This tells us that the base level is level 2. We've just selected that. We've got an offset we can use here if we want to. But again, we can manipulate the roof once we've drawn it. So it's not critical that you draw the roof in exactly the right location. We can modify its height once we've drawn it. So if we look up to the ribbon, we effectively have a copy of what was available in the floor tool. We've got some boundary line shapes that we can draw. We can draw the roof by a slope arrow. We have a green tick, a red cross, and these work plane tools. So basically what Revit wants us to do is define the edge of the roof, and it will build the roof for us. So if we click on a line tool or a rectangle tool, we'll start with a line. Again, we get these options in the next line down, and we can change some of these settings before we draw it. Chain, similar to the walls and the floor, it will create a chain of lines. It will just keep drawing line after line until we stop it, and it will define the edge of the roof that way. We can offset the location of the roof as we're drawing it. Now this is useful if you want to draw an eaves to your roof as you draw it. At the moment, if I draw the roof, it will draw the edge of the roof along the line, for example the walls underneath that I'm using. If I want to actually generate a eaves at the same time, if I set this offset to 1000 and then I start drawing my line, the line of the roof is actually out 1000 mil off the wall that I'm using as a reference. So it's a way we can generate the eaves line as we draw the roof. So ideally set that offset. The other one, the radius I won't touch. The other one down here defines slope. So this defines whether the lines you're drawing as the edge of the roof also tell Revit where the slope of the roof falls to. At the moment that's unticked, so every line I draw won't have any effect on the slope of the roof. The roof will actually be flat. If I click on that, then all the lines that I draw to define the edge of the roof will have a slope applied to them, and the roof will fall to those lines. So I'll draw them without the slope at this stage. Again, we can change all this later, but as illustration purposes, I'll draw it without defining the slope. So all these lines that define the edge of the roof will not cause a slope to appear on the roof. It will be a flat roof. So I'm just going to use these walls underneath, which I've drawn, and I can use the outside of those and snap to those and use those to define the edge of my roof. And again, I just quickly go around. You'll see I've got an offset in place, so it's drawing the actual edge of the roof 1000 mils outside the walls, and I just go around. And again, Revit needs you to complete the loop. You have to have a complete box for your roof, and we've now defined the outside line of our roof. Again, in the same way that the floor tool worked, we can create cutouts within that by creating other shapes inside that. I've got the offset set, which I didn't want to, but and we can draw circles and various things to define holes within our shape. So if I click on OK, it's going to generate a roof that's at level 2, floor level. It will have no slope to it, and it'll have these cutouts. So if I go to a 3D view, we've got a flat roof. The material we've picked is 150 mils tin, and we have these cutout holes, but we have no slope on our roof. And it's generated the roof at the level 2 floor level, which is here. In contrast to a floor, it generates the roof above the floor level. So whatever the floor level is, that's the lowest point of the roof when Revit generates it. So you can see the floor, the roof itself sits above the floor level. And we've got no slope, which is a bit of an issue. So if we click on the roof object, you can see all the properties for the roof are over here in our properties panel. We can change the type, etc. At the top, much like the floor, we have an edit footprint button. So we can redefine the shape of that roof once we've created it. If we click on that, we go back into the roof editing tool. We're in a 3D view. We can manipulate these lines within 3D, or we can go back to our level 2 floor plan, manipulate the lines there. I'm just going to stick to the 3D at the moment because it's just going to show what I'm doing a bit easier. So all of these lines are individual objects. If you hover over them, they're called model lines, and they define the shape of the roof. If I click on that one there, the properties panel tells me the properties of that line, and I can change the properties to suit individually per line. Again, we have this defines roof slope here, it's unticked. All of these lines are not defining roof slope. If I click on the tick for that one, you'll see we get a little 30 degrees next to it and a little triangle appears next to that line. If I click away, we get the triangle. So if I select that line, I can see that it's 30 degree and it's defining a slope. I'm going to change 30 degree because that's too steep. I want my roof to be 10 degree. So all I've done is tell Revit that this line here has a slope attached to it and the roof needs to slope down to that line. None of the rest of the lines have slopes, so none of the rest of those edges will have a slope attached to them. If I click on the green tick, you'll see it's now defined a roof that slopes down to that one line that I told it to, and the rest of them have stayed as they were. If I click on the roof and edit the footprint again, I might want this one to have a slope as well. Again, I need to make sure that it's got the right roof pitch, 10 degrees in this case. If I don't do that, if I left that at 30, Revit will define the roof based on the information you give it, and it will create a roof that has two roof pitches. It will take the information from each boundary line and generate the roof based on that. Again, edit the footprint. I don't want that to be 30, I want that to be 10. So I've now got a gable roof with a couple of holes in it. If I don't want a gable roof, I want one end to be a hip. Again, all I have to do is tell Revit that that line there has a slope attached to it, tell it what the slope is, and it will make the roof. So I've now generated a hip roof with a hole in it. If I want to get really complicated, go to my level 2 view, edit the footprint, grab that and move it across here somewhere. It will define the shape of the roof based on what I tell it, and it's now cut a hole in the roof through the hip. Again, if I go back to my roof, edit the footprint, I can change and cut out pieces of that roof. Say I want a little cutout in here. Now when you're in the line editing tool, you can, as I said before, you have to define a continuous single outline for the roof, otherwise Revit will have a bit of a fit. It can't figure out where the edge of the roof is if you've got conflicting lines. It doesn't know whether this piece of line here is the edge or whether this piece in here is the edge. And it can't define that as a whole because it's not complete in itself. So we have to tell Revit and tidy up these lines. If I try to hit OK, Revit would give me a warning and tell me I have to go back and fix it, and I need to edit the lines to be a continuous outline. The way we do that, we have these couple of tools up in here. Again, they're little tiny icons, but they're really important. One is a split element, and one is a split element with a gap. So if I click on the split element, which is SL as its shortcut, I get a little knife that appears on my cursor, and I can hover over any element, and there's a little cut line that appears as I move around, and it will tell me where I'm going to cut the element. So I just need to cut this line because at the moment it's a continuous line. I need to break it into two parts and create a gap in the middle there. So I click on that. I've now split the element in two. You can see that if I click on one end of the line, it's now separate. You can also see that I've now got two slope arrows. Because I've split the line in two and that line had a slope attached to it, I've now got two lines and they both have slopes. To tidy that up further, there's two ways I can separate this line. If I just drag the handle, you can see that I can actually create a gap in the middle of the line. I've actually got two parts to the line. The easiest way is to grab the round handle there, drag it back till it snaps onto the end of the other line, let go. I've now got a gap. The other way to do it is to use the trim tool, which is up here, another small little icon. If you click on that, then click on the two parts of the line that you want to keep, and it will tidy that junction up for you. So now we have a little cutout. We have slopes on the edges either side, but not on the piece that's cut out. And if I go back, generate my roof, back to my 3D, I've now got a cutout in my edge of my roof. So this is how we define the edges of the roof. If you have a parapet, for example, you'd want to pop the parapet through there and then redefine the edge of the roof so that it tidies up nicely against it. Again, this roof is sitting on floor level 2. If I go to elevation, it's sitting nicely with the lowest point on the floor level. If I click on the object, I can either move that roof up and down manually, or I can set an offset. So if I wanted the bottom of the roof, or the lowest point of the roof, to be 500 above the floor level, if I put an offset in, it will do that. Again, I've made sure these are tied together. It still is, so if I click on it, it's still attached to level 2, but I've created an offset. What that means again is if I move this floor level, the roof goes with it. It's important to make sure you keep these things attached so that when you change the floor level within a building, all the elements that should be attached to that floor level or sitting on the floor level will go with it. So I've got an offset on here, but I want to attach my walls to that roof. At the moment I've got a gap between the top of my walls and my roof. We have a really useful tool in Revit called attach base or top. If I click on the wall, I get this attach top base tool up here. I'm in the modify panel now. If I click on that, this allows me to attach walls to either a floor or a roof without having to manually do it. So when I've selected that wall, clicked on the tool, you'll get all these grade things, icons up the top. We have two options for the tool. We can attach the wall to the top or to the base. So this tells Revit we either want to attach the top of the wall to something or the base of the wall to something. It needs to know which one we want to do because it's not clever enough to know what our intention is. And then it will allow us to select the object we want to attach the wall to. Now, the wall can only be attached to roofs and floors. So as you move around your model, you'll see that I can't attach the wall to another wall. It's not highlighting. It will highlight the roof. It's saying yes, you can pick that, or yes, you can pick the floor. So if I click the roof, it will attach the wall to that roof, to the underside of that roof. So if I now look at that wall, you'll see that it now goes all the way up and attaches to the underside of the roof. Now in this end here, we have a gable. So when we attach this wall to that bit of roof, it will actually shape the wall to follow the roof line. Again, if we select two walls and attach the top, we can select the roof and it will attach the wall to those roofs. So you can grab all the walls at once and attach them to a single roof in one easy go. Now you might be asking why it's done this little weird thing with this wall, and that's because when I tried to attach it to the roof, if I look down on it, there's actually no roof above this wall, so it couldn't attach that piece of wall to the roof. And it said, well, I have to just basically stop the wall where it was. So we'll only attach walls up to a roof if there's a roof above them. If I go in and I manipulate the footprint of my roof and delete these little offsets that I created, close my gap back up again, go back in, you'll see now that it's actually gone and attached the wall up to the roof because I took out the problem. I've got a bit of roof above that wall now, and it's now cleanly attached the wall back up to that roof. I will point out, because it's important for later reference, that it hasn't actually changed the wall. It's changed the way the wall looks, and it now appears to be attached to the roof. But if you look at the properties for the wall, it's actually still only 2.4 high. And we know that the roof is sitting on floor level 2, which is 3 meters above floor level 1. The wall's sitting on floor level 1. So there should be a 3 meter height of that wall for it to attach to the roof. But the properties of the wall tell us it's only 2.4. What it's done is it's actually changed the way the wall looks, not the actual physical height of the wall. It's important to know this because it can cause issues when you're not aware of it, because you look at the properties of the wall and you think it's 2.4 high, and then you wonder why it doesn't reflect that in the actual drawing or the way it looks. So in all our elevations, all our walls look like they attach to the roof and go all the way up, but in fact they are still the same height. They always were, and that is 2.4. What it's done is it's created something called a profile. So if I click on this wall, I have the option up here to edit the profile of the wall. If I click on that, it's telling me it's going to remove the attachments before I edit the profile of the wall. So what it's saying is that those attachments to the roof are actually not real. They're part of a profile, and it's going to show me the wall as it actually is, not the way that it appears in this view. So I click on that, and I get this purple line which defines the outline of the wall in elevation. And you can see the top of the wall is at 2.4 above the floor as it should be, and it doesn't now look like it goes all the way up to the roof. If I cancel out of that, it will reattach the wall and it will look like it goes all the way up, but I can actually change the shape of the wall to something more complicated in elevation. So what I'm going to do first though is I'm going to unattach the wall from the roof so that I don't get that little warning and Revit doesn't get a bit confused. So if I click on the wall, now that I've got that wall attached to the roof, if I click on the icon next to attach top base, which is cleverly called detach top and base, it does the opposite. So I've got this wall attached to the roof. I click on that tool. I can now hover over objects in the model, and the ones that highlight are the ones that the wall is attached to, which at the moment is only that roof. And if I click on that, it will detach the wall from that roof. So now I've got the wall back to its proper height. It's 2.4 high, it now looks like it's 2.4. And if I click on the wall, edit the profile, I get a purple line defining the outline of the wall in elevation. So generally when you draw walls, they are drawn vertical and they are drawn in elevation to be rectangles. The top of the wall is horizontal, the bottom of the wall is horizontal, and that's the default way they're drawn. But we can change that by creating a profile for the wall. Again, we are not changing the wall itself. The wall is still modeled at the same height, but we're going to change the way that it appears in all the views. Again, I clicked on that. I've got this purple outline that shows the wall in elevation, and I've got these draw tools up here. If I take let's go with an arc. So let's grab a 3-point arc. If I draw a shape in here, like that, and then I draw just a line to connect that up to there. Again, I need to create a continuous single outline for my wall elevation, otherwise Revit gets upset unless I'm creating a hole in it. So if I draw a shape that is completely within that outline, Revit can live with that. But at the moment I've got this nice straight line here, I've got this little cutout, but I'm confusing Revit because I've got two lines that define the edge of the wall at that point. So again, if I select that line, go to the cut tool, split element tool, grab that, I can just grab the handles, open that up again. And I've now got a nice continuous single line around the profile of my wall. If I click OK, I've now generated a wall with a cutout on the top and a hole in the middle of it. If I go to my 3D view, that's what I've got. So I can change the shape of the wall, this profile of the wall. You can do that to any of those lines around that define the elevation of the wall, and you can make them any shape you want. Again, the wall itself has not changed. If I click on the properties of the wall, it's still a 2.4 high wall. It just, Revit redraws it in a way that makes it look like it's got a hole in it. And it doesn't actually affect the properties of the wall itself. To explain that a little bit further, again, if I edit the profile of that, and this time I want to make a, let's go with a curved line that way. So I want to do something like this with the top of my wall. I'll drag that down to there. And I'll trim that. So I've now got a curved top on my wall. Again, if I go back, I've got that shape on my wall. If I go to my 3D view, it's curved. If I click on the wall and look at its properties, the height of the wall hasn't changed. Even though I've just made the wall taller with a curve, the wall itself is still 2.4. And if you look at the wall, you can still see the actual top of the wall through here as Revit understands it. So we're manipulating the way the wall looks, but not necessarily changing the properties of the wall itself. If I don't want that profile, if I select the wall, next to the edit profile button up here we have reset profile. That will change it back to its previous shape. And if I want to, I can attach that wall back up to the roof. So that's how we generate floors and walls and roofs. The last thing I want to touch on in this video is lines. We have two types of line within Revit. So with this view here, this 3D view, we're dealing with modeled elements. These are physical things that appear in 3D space, and we can rotate around them and we can see them in multiple views. So if I go to my elevation, this wall here is the same wall that I can see in the 3D view, and it's a physical object. It's a modeled element. But we have two types of lines within Revit that we can use. One of them is a modeled line or a model line, and the other one is a drafting line or a detail line. So if I go back to my floor plan, I've got this lovely shape here. The general line that you will use on most views to draw things is a detail line. So it lives in the annotate tab. It lives up here. It's got a little icon. DL is its shortcut. So we use detail lines when we're drawing details themselves, or things we want to appear on a view, but don't necessarily want to appear as part of the model itself. So a detail line is a line that only appears on the view and doesn't appear in multiple views because it's not actually physically there. So if I click on the detail line tool, cursor changes, I get these draw tools again. I've got different line styles, which I'll cover later, but it allows me to just draw lines on the view that have no effect on anything else. If I go into my 3D view and delete my roof, and I look down on that floor, you'll see that those lines there that I've drawn only appear in that view and don't appear in the 3D view. They're not really there. They're just lines that we can use to illustrate or fill in blanks in the floor plan, but they're not actually real. So whilst I have these detailed lines in my floor plan, if I go to the 3D view, they're not there. They don't appear. They only exist in the view that I drew them in, and they live parallel to the plane of the view that I'm looking at. So if I draw a detail line in my west elevation, deleted the roof, if you're wondering where that's gone, I can draw detail lines on this view, and they appear to be on the walls, but again in the 3D view they're not there. They're not real. They don't exist. They're purely in that elevation that I drew them in. If I want lines to appear that are actually a 3D modeled element, we have something called model lines. So I can draw a line that is physically in 3D space, and I can see it in all the views, and it will rotate around with my 3D view and appear in all the views that see whatever that line is drawn on. So that line is called a model line. And if we go back to the architecture tab, model line lives down here. LI is its keyboard shortcut. If I click on that, I get a little pop-up box. So the problem we have with lines in space is Revit wants to know where they are. At the moment, if I drew a detailed line in this view, it appears effectively at the very front, on the cut plane itself. Revit doesn't need to know how far forward or back that line is, it just appears. When I draw a 3D line that's actually physically in space, Revit needs to know where it is forward to back in this view, because it could be in front of the wall that I'm looking at, or it could be way back, 30 meters beyond the back of this wall here. So Revit needs to know what it's going to draw the line on, and again, this concept of hosting. The model line needs to host on an object or a plane, otherwise it doesn't know, Revit doesn't know where it is in 3D space. So I've got some options here. So this is a work plane box. This pops up when you are trying to define where you're hosting objects or creating a plane that you're going to draw on. It's quite a common box that pops up, and we're just going to run through it as part of the model line explanation. So at the top here we have the current work plane, which at the moment we have none. We've not set a work plane, and we have to specify a new work plane. Again, definition wise, work plane is the line in space, forward or back in the view, that we're going to attach whatever we're working on to. So we need to show Revit or tell Revit where we want forward or backwards in the view in 3D space, what plane we're going to use. So we have some options. We can specify a new work plane. We have three buttons. We can either select it by a name, we can pick a plane in the drawing, or we can pick a line and use the work plane it was sketched in as the work plane for our new line. We're going to ignore the last one at the moment. It's a little bit complicated. But if I click on name, we've got a drop down menu here, and it will show us any named planes that are within the view or the model. So at the moment we have two grids, one in A and and 2 floor levels, 1 and 2, that are defined as planes within our model. I'll just cancel out of there for a second. So these grids here, this is grid A. Grid 1 is actually running parallel to the view plane that we're looking in. If you remember, it sits here, and we're looking at this elevation here. So this grid line 1 runs across parallel to the view plane that we're looking at for the elevation, which is here. So we can't see grid 1, but it is actually a valid plane that runs across our drawing, our view. So when we come to pick a plane, work plane for our model lines to go on, grid 1 is actually ideal. It defines a forward and backwards location within this view. So we could use that to define where our line goes. We have other options there that we can use, and we can create other reference planes to use as lines for our work plane. So if I decide to click on grid line 1 as our work plane, Revit's happy with that, I click OK, and it will now let me draw a model line. Again, we have the same tools as our detail line. We've got all the draw tools, the line styles, etc. So I'm just going to draw a line randomly up and down on this view. And I click escape to set that in place. So I've now got this line here. Now this line is a model line. This line here is a detail line. They look essentially the same, but they are quite different. This one exists only in the view, it's a detail line. This one exists in 3D space. If we go back to our 3D view, we'll find we've now got this line here, which is the line we just drew, the model line, and it's actually physically there in our model. And it sits on grid line 1, which is why it kind of floats out in space a little bit. So that may not be what we're after. So let's draw another line and show another way of selecting a work plane. I go into my model lines again. It is by default using the last work plane that I told it to use. We can tell that because placement plane here tells me we're on grid 1. And it's going to draw the next line on that same work plane. If I want to change that once I've already selected it, if I click on pick, we go back to our work plane box. And if I don't want to use any of these named planes here, I can pick a plane within the drawing to use as a work plane. So you'll see why this becomes useful in a second. So if I just click on pick a plane, it's not asking me for anything else at this stage. Click OK. It now changes the cursor and it's highlighting or selecting objects within my model. So it's wanting me to pick an object that I want to use as the work plane for my line. Now I can either select single lines, or if I hover over a face, you'll see there's a blue line around the outside of that entire face. If I select a single line, it's using a work plane that is not parallel to the view. It's picking, this instance, the top of the wall, and the top of the wall has a face on it or a work plane, and we can select that, but that's not what we want to use. So if we hover over the wall itself, it will come up with a little blue line around it. If I click on that, that's now defined as the work plane for my lines. I'm in the model line tool, and I can draw a line like that. Again, that line now is physically in space, and I can rotate around it and I can see it. I can see it in all the views, and it's living and hosted directly on the wall face itself. So that's how we draw model lines and detail lines. Model lines are incredibly useful for adding detail and texture to drawings, but in a way that is actually visible in all the views. So you might want to add lines that represent battens on a face of an elevation, or a logo for a company. You can actually do those in model lines, and they are created as a 3D object within the model itself. So that's all I want to cover on this particular topic. We've covered floors, walls, roofs, how we create those, how we modify them, and also how we draw model lines and detail lines, and how we define work planes.